Hello and welcome! In this lecture we're going to add obstacles to our pathfinding. Okay, so here we already have pathfinding working. So I can put my mouse somewhere, press the T key, and there you go, it calculates a path going from 0, 0 onto wherever the mouse is. So going there, it goes through here. If I put the mouse there, it goes direct. If I put over there, it goes through there. If I put there, and so on. So the pathfinding logic is all working perfectly, but right now every position is walkable. So let's add some obstacles to make some nodes unwalkable. And actually, before we do that, let's go here to our pathfinding script and finally implement that setup function. So let's make the connection with the level grid. So we only need to define these values in one place. So let's do that. Let's make a public void, call it setup. And here let's receive an int for the width, an int for the height, and a float for the cell size. Then we just set them. And over here we create the grid system using these parameters. So let's go pass in, over here pass in the width, then the height, finally the cell size. Alright, so now we just need to call this function. So let's go into the level grid. So here we are. We instantiate this one on wake, okay? Then let's make a private void start. And over here on start, let's go in pathfinding, access the instance, and call setup. And let's pass in those three values. So instead of copying the values again, let's make sure to only define them in one place. So let's actually copy these definitions, paste them over here on the level grid, except for these ones, let's make them serialized fields. So we can set the size of the actual grid in the editor. Okay, so let's assign those exactly as we have here, so 10, 10, 2. In order to make the code compile, let's just comment this out. And here in the editor, let's find the level grid, and over there, let's put 10, 10, 2, okay. So now here, let's use these values. So when creating, we've got the width, then we've got the height, and finally we have the cell size. And then on start, let's go into pathfind, the instance setup, and over here pass in the same thing, the width, the height, and the cell size. However, we also need to make sure that this runs before all the actions try to do something with pathfinding. Like for example, maybe we have an action where on start, it's trying to validate something to see if a certain position is walkable. So let's make sure that both these scripts, both the level grid and the pathfinding, make sure both of them run before anything else. So doing that is like we've seen before. Let's go into edit, then go into the project settings. And here let's find the script execution order. And then let's just drag those two. So let's drag the level grid and also find the pathfinding. And then let's put them before the default time. So before that one and that one. Okay, that's it. Let's hit on apply. And now let's test to make sure everything still works. So here we are, I can still click, yep, I can still move, and I can still press T, and yep, there I go, still calling the pathfinding. Okay, everything's still the same as previously. Now with this, let's add some obstacles and make some nodes unwalkable. First, let's handle the logic for doing that. Let's go here to the path node script, and over here, let's just add another field, so something pretty simple. So a private bool is walkable, and by default, let's default this to true. So by default, it is walkable. Then we're going to need to grab this, so let's expose it. So a public bool is walkable, and we just return, so just return is walkable. And also we're going to need to set it, so let's do that as well. So public void set is walkable, save a bool is walkable, and we just set it. Alright, that's it. So now all we need to do is go into the pathfinding script. So here we are. And over here, let's go down to our find path function. So here we are, find the path. So we're running all of the algorithm. Yep, all of this. Then as part of the algorithm, we cycle through the open list. Then for each current node, we're cycling through the neighbors of that node. And over here, we check if it's already on the closed list, we skip it. And then after this, let's add another check. We're basically going to check if this neighbor node is walkable. So if neighbor node.is walkable. If it is walkable, then we're going to test. But if it is not walkable, then we basically want to skip this. So let's first add it to the closed list. So closed list, let's add this neighbor node, and then let's continue. So this way we skip all of the nodes that are unwalkable. Okay, so that's really it for the code. Super simple. We just skip nodes that are unwalkable. Now for testing, let's make some of them. So let's go up here into our setup. So we've got our grid system, okay. Then here, let's just set some nodes. So let's get, for example, get the node, let's say on 1, 0. And call set is walkable into false. And let's also do the same thing on 1, 1. Okay, that's it. So let's test. So here we are, and we have manually marked these two positions, 1, 0 and 1, 1. We have manually marked these as unwalkable. So now if I put my mouse in here and I press on T, we should be able to see the path go from here to there, then there, there, there. So it should avoid the unwalkable areas. So here I am, press T, and yep, there you go, there it is, exactly the path we wanted. All right, awesome. So that's really it for adding obstacles. That's the only logic that we need. Just mark it as unwalkable and that's it, everything works. So now instead of obviously doing this manually, let's do it with some proper logic. So let's make some visual obstacles and then handle the is walkable automatically. What we're going to do is basically cycle through every single grid position. So go through this one, this one, this one, this one, and so on. And on every single one of these, we're going to do a raycast on that position. We're going to do the raycast on some kind of obstacles layer. And if it hits something, then we're going to define that point as unwalkable. If not, then it stays walkable. Okay, so let's do that. First, for handling the obstacle, let's go into our project files. So we've got the Polygon prototype pack that we imported quite a while ago. Let's go inside the prefabs folder. Here we've got buildings, and inside the simple, we've got a whole bunch of nice ones. First up, let's just place some simple walls. So let's drag this one, so the wall 1x3. So here it is, it's a very simple wall. Now we're going to do a raycast only on the center of each grid position. So let's make the wall a bit thicker just so it's easier to position. So let's modify on the wall transform. Let's set the scale to 10 so it's a nice thick wall. And then we can play around with the X. So put it like this, so a big or a small wall. So let's put the X scale on about 4. So pretty much something like this. So you've got a wall. It's nice and thick and should work perfectly. Now something extremely important is to make sure that this wall has a collider. If it doesn't, then the raycast won't work, so make sure it has a collider. And right now, yep, if we hide the visual, we do see, yep, there is the wall collider, okay. And finally, in order to test which objects are obstacles, let's make a layer for them. So on the inspector, let's go into layer, let's add a brand new layer. For this one, let's call it obstacles. Then let's select the wall again and set the layer into obstacles. Okay, so that's it. So this is the basic wall that we have set up. Let's make this into a proper prefab. So let's go into our prefabs folder and drag the wall. Let's make it an original prefab. And let's also rename this. So instead of this complex name, let's just name it wall. And on the hierarchy as well, also rename it to wall. Okay, that's it. That's the basic wall. Now let's make the logic for automatically cycling through the whole map and doing the raycasts. Over here on the pathfinding script, we're on the setup function. And first up, let's get rid of these manual set as walkable. So let's do that automatically. Let's cycle through the width and the height. So for int x, let's start off at 0. Under the width, x++. Same thing on the for int z. Then here we have our grid position. Grid position equals a new one on this x and this z. Okay, so now here, like I said, we're going to go into physics and we're going to do a raycast. Let's use this version, which takes an origin, then a direction, a distance, and a layer mask. So for the origin, that is in world position, so we need to get that. Let's do a vector 3. For the world position, we need to go into the level grid, access the instance in order to get the world position of this grid position. Okay, so we have this, and this is our origin raycast position. However, just like this, we actually could have an issue. And the issue is that the raycast does not trigger if its origin is already inside a collider. So here in the editor, for the world position on the grid, it's going to be right around the bottom. And at the same time, the wall is also placed right on the bottom on y of 0. So if the point that we're going to test, if that one is inside this collider, then it won't work. We need to fire the collider from outside. So a simple solution is just to offset the raycast either up or down. So instead of using that position, let's offset it down by a few units, and for the direction, we're going to point straight up. Okay, so we have the world position, then let's just add a vector 3 dot down. So we're going to point down by some offset. Let's call it the raycast offset distance. Let's put it by about 5 units, that's good. So here we move it down by that distance, okay. Then for direction, we're going to point straight up, so vector 3 dot up. Next up, for the distance, let's go with double the offset distance, so raycast offset distance multiplied by 2. It just needs to be more than that, so we actually go back to the point that we actually want to test. So with this method, we are avoiding that problem where the raycast does not work if it's fired from inside the obstacle. But also, since this is a teaching course, let me mention another solution to this problem. Here in the editor, you can go into Edit, then go into the Project Settings. And then if you find the Physics tab, over here there's a toggle for Query Hit Backfaces. Basically, if you enable this, then you can spawn a raycast from inside a collider, and it does work. So those are the two solutions. You can either enable this and it won't work from inside it, or you can leave this on default and offset the raycast just like we did. So let's use that approach of applying a offset. So here we have all parameters. All that's left is the layer mask. So let's go up here to define it. Going to make it of type a serialized field, private layer mask, and call it the obstacles layer mask. Okay, so then down here on the raycast, let's use this layer mask. Let's just put these parameters to the side so they're easier to see. So we point down, point up by that distance with this layer mask, okay? Let's just save and go into the editor. And here let's set that layer mask. So let's find the pathfinding game object, and on the obstacles layer mask, select just obstacles. Okay, great. So we've got our raycast, and again, this is a boolean. So if this returns true, then that means we have an obstacle on this grid position. So we do an if. So if this is true, then there is an obstacle on this grid position. So over here, it's very simple. Let's just get the node. So get the path node on this X and this Z, and we just set it is walkable into false. All right, so that's it. Some very simple logic. Cycle through the whole list, see if there's anything in there. If so, then it is unwalkable. If not, it is walkable. So before we test, let's place the wall somewhere. So let's grab the wall game object and let's put it somewhere around here, maybe rotate it upwards, something like this. So basically these two grid positions, let's just make sure they are occupying the exact center point of the grid position so the logic works. So basically these two won't be unwalkable. So the unit should be able to go around this. So let's hit play. Okay, so over here, these two grid positions should be unwalkable. So by testing, if I put the mouse here, it should start here. So it should go from here to here, then should go in there, there, and there. So here, press T, and there you go. It does exactly that. So now it avoids the obstacle. All right, awesome. If you want to make sure, let's test with a few more walls. So let's duplicate this one. Let's put it somewhere like this. Put it maybe a bit bigger in there. Okay, let's test. So here we are, and for testing, the test starts off at 0, 0. So if I place the mouse here, it should go around here, here, here. So here, press, and yep, there you go, it does exactly that. All right, great. So here we added the logic to support obstacles by making some grid positions walkable and some not. The pathfinding map is all created automatically, so all we need to do is just add some obstacles, and the system automatically defines which positions are walkable and which are not. That makes it super easy to build some levels, so with this, let's build a proper map in the next lecture.